Good morning or good afternoon. Today we're going to be talking about vertical asymptotes and what's called a hole in a graph. We'll get to that in a second. We've also got some new symbols that we're going to start looking at. These are our first calculus symbols, since this is a pre-calculus class. And in calculus we look at what are called limits. And a limit means what's happening as something is approaching something else. Not what happens when it's actually there, what's happening as you approach. So like, for example, you're walking home from a friend's house. I'm not talking about what happens when you get home, because maybe you're late for curfew or something, but what happens as you approach. What's happening those last few seconds as your hand is reaching up for the door, and what's going through your mind? Are your parents going to be mad at you? You're coming home late. Again, that's what approaches means. It means not when you actually get there. That last moment right before you get there. All right, so we got some notation to learn. All right, so the first notation right here. It says as x approaches a, and then there's a little plus sign after the a. And that little plus sign, it's kind of almost, it looks like it's a little bit like a power or an exponent, but it's just a plus sign. It means we're approaching something from the right-hand side. So if you look at this picture right here. Right, here is A. A is this location right here. And it looks like we've got this graph over here. What we're looking for is what's happening as I approach. It means, and again, from the right. So as I'm coming in from the right, what's happening as I get closer and closer and closer to A. Not what happens at A, because what happens at A is an asymptote. We want to know what's happening as we get closer and closer and closer. So as you're coming from the left, it looks like we're getting higher and higher and higher towards infinity, because that's an arrow pointing up forever. So what we would say then as an answer is that x approaches infinity. All right? So again, as x is approaching a from the right, you can see the answer down here at the bottom. The value of the function, f of x, is approaching infinity. It means it's going up. All right? Now, what about the other direction? What happens as you approach A from the left? So here's a second example. And again, we have that same location for A, except this time we're coming in from the left-hand side. But it's also pointing up towards infinity. So we'd have the same answer. As x approaches A from the left-hand side, the value of our function is increasing towards infinity. Everything happens the same way if the things are pointing down. So if we are in this third graph here, it says as x approaches A from the right, so again we're coming towards A from the right, we're coming in this direction, we're headed down towards negative infinity. Right? And then last but not least, in the last graph, we're looking as x approaches A from the left, so again we're coming from the left, telling us again what direction we're headed towards from. Coming from the left, and it's pointing down. So again, the value of the function will be headed towards negative infinity. So the first part of your work today is just kind of recognizing some of these symbols. Nothing too crazy hard, but just kind of getting used to some new notation and symbols that we're going to be seeing. Not too often, but again, it's a pre-calculus class. We'll see some bits and pieces. All right, so what is this all about? So in the graph, there's a couple of weird things that can happen. First off, we can have a hole in a graph. Right? Holes occur when the same value of x makes both the numerator and the denominator equal to 0. And again, it would come from any canceled out terms. And you might be asking yourself, what's a hole in a graph look like? Well, if I have a line that's moving along, and instead of an asymptote, we have a hole. It's a spot where the graph completely skips over a particular answer. All right, so it's similar to an asymptote because we don't have any answers there, but it's not approaching that dot without bound towards infinity or negative infinity. It's just essentially skipping directly over it. So it's a little bit different. All right, then again, a vertical asymptote, those occur when the value of x just makes the denominator 0, not the numerator, just the denominator. These would come from any non-canceled out terms that are still left in the denominator. We worked on this a little bit yesterday. And again, what those are is vertical lines, and the graph will approach it but never touch. It's a hard concept to think about, but that's what's happening. They're never going to touch, but they're going to keep getting closer and closer and closer. All right, so let's take a look at what today's work is going to look like. All right, we're going to have some problems, some rational functions. It means there's going to be variables in the denominator. And we're going to be asked to find the vertical asymptote, which we worked on yesterday. And now let's see if there's any holes. So the main idea here is we have to do some factoring in both the numerator and the denominator. So if I did some factoring in my numerator, let's see, that would give me x. And the numbers that would multiply to make 15 could be 1 times 15 or 3 times 5. And I also need those same numbers to add or subtract to make a negative 2. It's got to be the 3 and the 5. A 15 and a 1 will never subtract or add to make a 2. So when I do add them, I get a negative 2 answer. And when you add and subtract, you keep the sign from the bigger number. So that negative sign came from the 5. Now, when I multiply, a negative times a negative makes a positive, but I don't want a positive. I want to multiply them to be negative 15, so I need 1 minus 1 plus. Again, you can check your work. Negative 5 plus 3 makes negative 2. Negative 5 times 3 makes negative 15, so we know we did that right. All right, denominator. Looking for things that multiply to make 10, so that's 1 times 10 or 2 times 5. I also need that same pair to add or subtract to make a 7. It's got to be the 2 and the 5. All right, when I add them, I get negative 7, so the bigger number was negative. And again, a negative times another negative would make a positive. That's how I'll get the positive 10. Negative 2 plus negative 5 adds to make negative 7, so everything checked out. All right, so the reason I did that is because I was hoping that I would get some things to cancel, and you can see I do here. These x minus 5s will cancel. All right, the canceled out part is where I'm going to get my holes from. So to find my holes, I would essentially be looking for what thing makes that numerator and denominator a 0 at the same time. Again, that has to be matching numerator and denominator. So if I solved that, I'd add 5 on both sides. Oh, okay, there we go. At x equals 5, there would be a hole in this graph. Right now, the vertical asymptote. That's the part we worked on yesterday. That would be the remaining parts just from the denominator, setting those equal to 0. And x minus 2 equals 0. I just add 2 on both sides, so I got a vertical asymptote at x equals 2. So again, you're factoring the part that cancels out. Still go ahead and solve it for 0 because that's where your hole would be. And then the part that didn't cancel out, just the denominator part, set to 0. And that will be where your vertical asymptote is. If you're wondering what on earth something like this would look like graphed, and we got a vertical asymptote at 2, so there'd be an asymptote over here, which means, again, the graph might be coming up towards it like this. And then we got a hole at 5. So over here at 5, maybe on the other side of that, at 5, there's a hole, but the graph doesn't jump at that place or point towards anything. It just skips over that dot. All right. Hopefully this makes some sense. A lot of factoring. So feel free to get me on the Zoom if you need any help or just want to check any answers. Good luck today.